Welcome to the CERIAS seminar series for April 18th. Today we have with us Mercan Topkara. Mercan is a graduate student here at Purdue, expecting to complete her PhD in the next few months. She has her undergraduate degree from Bilkent University in 2000 and has been here, arrived here in 2001, and has an extensive publication record in various aspects of computer security, but we'll be talking to us today about issues in integrity, and in particular integrity of natural language texts.
Thank you very much for the introduction. I'm Mercan Topkara. I'm a PhD candidate here. I will tell you about a topic that probably you didn't hear much of before. It's about natural language watermarking. For example, we're living in a digital age, and this is a typical page from internet, and you see a lot of objects on this page: an image, a video, a text, audio. You can even get the audio. And the other part that we are very much interested in is your say. This part. You can put your content on the internet now, and it's pretty easy. But the trouble we have is, how can you have the control when people are reusing your content? When it is being distributed, you lose your control over the intellectual property of this. So we have to come up with a way so that the digital content property protection of the owner is provided for text as well as other things on the internet. Before going into details, I really want to acknowledge my collaborators. I have closely collaborated with Professor Atala from Computer Science, Professor Dab from ECE, Purdue, Dilek Hakkani Tür from University of Berkeley, Victor Raskin from Computational Linguistics at Purdue, Giuseppe Riccardi from University of Trento, Cüneyt Taşkıran from Motorola Labs, and Umut Topkara here from Purdue. And I have also collaborated with Shirini Bangalore from AT&T Labs and Owen Rambo from Columbia. And you can as well reach to these people if you have any other questions about this work. Our problem is controlling how the information we create is distributed or reused, as I have mentioned. So how can you be sure your emails are not being reused? For example, you have put time to write an email that has a very meaningful, important content, or a blog, or a wiki edit, and you don't know whether people are using it. Or even your articles, whether they are being published in another conference but by other people. Also, there is another aspect of it. As a reader, how can you trust an email you're receiving from your bank that is really from your bank? And so we need a rights protection system that travels with the content. When we say travel with the content, is different from digital signatures. When you remove something from when you open digital signature, you can copy and paste the text. The problem with text is it is very easy to copy and paste, use it partially, insert in it. It is different from image or audio. Even non-tech savvy users can do that, like copy paste the text. Our approach to this problem was information hiding, which I will tell you more about. So I have assumed that my talk will be all assuming that you have no background about anything that I'm talking about. So I will be going through as fast as I can through the required background. The first thing is information hiding. It has two main branches: watermarking and steganography. Steganography probably you heard of. It means hidden writing. It is based on covert communication. So you see here an Arctic hare on the top. It's pretty wide for this display, but that Arctic hare in fact carries the picture of that jet plane in it. So it is a steganography where people are just sending the picture of Arctic hare image, but they're also sending the picture of that jet plane. And it is a typical image that you can receive as a forward from one of your friends. So steganography deals with how you can perform this covert communication, and also steganalysis, how you can detect that there is a covert communication going on. Watermarking, which I will focus more in this talk, is about content protection, as I have said. There can be several types of it. A typical example is a visible watermarking example that you see. That small icon has the IBM logo in it as a visible watermark. You can see it if you look at it very carefully. The other type of it is invisible, which is much more robust because it uses several techniques from signal processing. You can also try to do a fragile watermark. For example, you wrote a document, you don't want people to tamper with it, or you want to detect if it is tampered and deny that I'm not the owner of it, somebody tampered with it. And the other type is the robust watermarking. You can use it for fingerprinting, metadata binding, copyright protection. We'll talk more about this. What is natural language watermarking? It is a way to enable copyright holders to enforce their intellectual property ownership on text, which I have been telling you more about. But here there is another detail we need to discuss. What is the value of the text? Because I want to preserve the value of the text while I'm embedding your copyright information into text. So throughout this work, we have defined the value of text as meaning, grammaticality, and style. So, for example, meaning is important for not disturbing the communication. Grammaticality is as well. Style is a different issue where the author really wants to preserve his style while you're embedding the information. So we want to mark the text such that we do not reduce the text value. Also, the adversary is forced to reduce the text value when he wants to undo our embedding, when he wants to remove the watermark. Why do we need natural language watermarking? One thing is that I have been telling you, authenticating the source of the document. The other is proving or denying of the ownership of a document or controlling the distribution. There are several applications of digital watermarking, like digital libraries, online newspapers, or stores. And the last bullet tells about the typical watermarking applications like content protection, text auditing. This is a very simple example. It's in fact a mock-up example because it is very hard to achieve this with a system, which we will be talking in more details. So the top sentence you see is from the abstract of this talk. It is the original one. And later we have a key, which is a secret key, and a message. Here, another principle we follow in watermarking is Kerckhoffs's principle. We don't have security through obscurity. The only thing that is hidden is the secret key. Using this key and the message, I want to change the top text into another text so that it carries the message. I can do several changes. One of them is paraphrasing the first part of the text, where I say one of the main sources of knowledge acquirement is the internet, instead of the internet has become one of the main sources of knowledge. I can insert new words like witches, or I can do synonym substitution. But the challenge here is how to perform this fully automatically, not without using any human intervention, which we will discuss in more details. One of the traditional challenges we have compared to other watermarking schemes, like for images or audio, is the low bandwidth. Most of the documents are short. For example, if I insert only one bit into one sentence, if I'm talking about an email, for example, it has 10 sentences, 10 bits of information might not be enough to prove your case in a court. So, and the other thing is, even if I have 10 sentences, I might not be able to change all of them. Because, for example, here I put up an example, like, I run by the river every morning. I want to insert some information in it. For example, I can try to my system automatically can think that it's a passive sentence, and it can try to rewrite it as the river run me every morning. It is grammatical, but it's meaningless. Or I can do synonym substitution. I can change run into manage. I manage by the river every morning. It is not meaningful. The other thing is the last sentence. It is grammatical, it is meaningful, but it is not very common. Like, the author might not want to say, I don't not run by the river every morning. Another challenge we have is the powerful adversary. He can automatically edit individual sentences. He can permute the sentence order, which is very hard to do in an image without being noticed, or can delete or insert new sentences. Here, sentences, I mean the units that I'm using for embedding information and detecting it. And also, he has access to the same data and software resources that I have used for watermarking. So, this is another background slide that I added here. In order to perform this watermarking automatically, we use natural language processing tools. This is a research area under computer science, under computational linguistics.